Alright, so today we're going to be looking at some compound events instead of just simple events and trying to find the probability of some different things happening. So we've covered simple events, which is just a one-time event. You flip a coin once, you pick a marble once, you spin a spinner once, something like that, just one time. Compound events, just like when we studied compound shapes, it was more than one shape. So compound events are multiple simple events. So you roll the dice now 2 times, and what's the chance you get a 6 on both of them? Okay, different than rolling 1 dice and just saying, what's the chance of getting a 6 on just this 1 dice? It's much different once you add more dice or you roll it multiple times. Okay, so we're going to talk about 2 different methods. Both of them work. One takes a little longer than the other, but sometimes it's easier just to fall back on, and it's more of a visual too that will help explain kind of why the second method, which is faster, works. So we're going to start with the tree diagram, and that's just starting with all the events that could come first, and then it branches off to your second events. If you had to go to third and fourth events, it'd be even more, but that's when this gets a little complicated. But for a simple 2-event demonstration, the tree diagram is actually very helpful. So here's the question: how many total outcomes are there from rolling a dice 2 times? So you roll the dice once, we know there's 6 outcomes, so we're going to call that 1, 2, 3, 4, 5, and 6. So the first time you roll that dice, those are your only 6 options. You pick it up, you roll it again now for a second time. There's only 6 options the second time, but there's a whole bunch of different combinations based on what I rolled the first time. So if I roll a 1 on my first roll, the next time I roll, I could again roll a 1, 2, 3, 4, 5, or a 6. Okay, so I rolled a 1 on the first time, and then the second roll I can still get anything 1 through 6. Or maybe I rolled a 2 on the first try. Well, on my second roll, I could still have a 1 through 6. So far, here's all the different combinations. I could have rolled it and got a 1, and then rolled it again and got another 1. Could have rolled a 1 the first time and then a 2, a 1 and then a 3, a 1 and a 4, 1 and a 5, 1 and a 6. Or maybe I got a 2 the first time, and then I got a 1, 2, 3, 4, 5, or 6. Or maybe I got a 3, and then I rolled a 1, or a 2, or a 3, or a 4, or a 5, or a 6. So far, every single one of these little strings or branches represents a different combination. Here I've got a 1, 1, and a 1, 2. Nowhere else here do I have that combination. I could have a 2, 1, okay, but the 2 came first and then the 1. So that's a different outcome than a 1 and then a 2. So the order here matters. So for 4, 5, and 6, it's the same idea. You got a 4 on the first roll, and then there's 6 different things you could get on your second roll. Same with 5 and 6. So each branch represents a different combination. None of them are repeated here. A 1 and then all of them, a 2, then all of them, a 3, and then all of them, 4, 5, and 6. So 1, 1 is an outcome, 1, 2 is an outcome, and 1, 3 is an outcome. So is 6, 1, and 6, 2, and 6, 3. So each one of these branches is a totally different outcome now. So we don't have 6 total outcomes. We've got 6 here, 6 here, 6 here, 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 and here. That's a total of 36 outcomes. We have 36 different combinations here. Okay, now this can get a little complicated, especially if we rolled it a third time, and now every single one of these has to have another 6 branches. Okay, then it gets super complicated. But this is a good visual of all the different outcomes, 36 of them. So now let's use this to find out some of these probability questions. So first one, what's the probability of rolling a 5 on your first roll? So that eliminates this, 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 and this. So we're only looking here. Okay, what's the probability of rolling a 5 on your first roll and a 6 on your second roll? Now remember, it's total outcomes on the bottom. and favorable outcomes on top. So the total outcomes here is 36. When you roll a dice 2 times, there's 36 different combinations that could happen, and we've demonstrated that here. Now, how many of these combinations give you a 5 on the first roll and a 6 on your second roll? Not here, not here, not here, not here, not here. Happens here with a 6. So 5-1 doesn't count, 5-2 doesn't count. The only combination out of these 36 combinations that works is a 5 and then a 6. So that's a 1 out of 36. There's not 2 combinations, there's just 1. 5-6. So 5-1 doesn't count, 5-2 doesn't count, none of these count because it said specifically 5 on the first and 6 on your second. Now we're going to come back. The order matters here because it said 5 on the first, 6 on your second. It didn't say just a 5 and a 6. That would change the question. So we'll come back to that. So there's only one way to get a 5 and then a 6 out of these 36 combinations. So 1 out of 36. Now, what's the probability of rolling 2 even numbers? So again, it's out of 36. And if I'm going to get 2 even numbers, then my first roll can't be odd. So I'm not looking at the 1, the 3, or the 5. So the only combinations is a 2 and a 2, a 2 and a 4, a 2 and a 6. That's 3. 4 and a 2, 4 and a 4, 4 and a 6. That's another 3. So 6 total. And then same thing with the 6. 6, 2, 6, 4, 6, 6. That's 2 even numbers. So 3, 3, and 3. That's 9 different combinations out of the total of 36. And we can simplify that. You can divide right now by 9. And you have a 1 out of 4 chance of rolling 2 even numbers. So if you rolled the dice 2 times, and you did that over and over and over, out of every 4 times, you should get 2 even numbers once. Now, that doesn't happen every single time, but those are your odds. Now, what's the probability of rolling 2 4s? So this is out of 36 outcomes. How many times do we see 2 4s in a row? Well, we can't possibly have 2 4s if we start with a 1, 2, 3, 5, or 6. So we're just looking up here. Okay, we got a 4 and a 4, and that's it. That's the only combination out of these 36 that has 2 4s. So that's a 1 out of 36 again. Now here's the question I was talking about. What's the probability of rolling a 3 and a 5 in any order? So you could roll the 3 and then the 5, or you could roll the 5 and then the 3. So there's 2 combinations or 2 outcomes here that has a 3 and a 5 in any order. So it's 2 out of 36. And that's equal to 1 out of 18 if you simplify. Okay, so this is very helpful once you've got this tree diagram made, but sometimes making the diagram can be very time consuming. Okay, and there's another method that's much, much faster, but sometimes can be a little more complicated in terms of understanding. But once you've got it, it can be very fast. So method number 2, the counting principle, says that the probability of an event M, which is just your first event, followed by an event N, your second event, is equal to the probability of your first times the probability of your second. M and N just represent the events. So the probability of the first event, whatever that is, times the probability of your second event. So you're just going to look at the 2 events, find the probability of each one on their own, and then multiply. So that's what it says right here. Multiply the probability of each event together to find the probability of both happening back to back. So we're going to go through the same questions, but use this principle, and then, of course, we're going to get the same answers. So what's the probability of rolling a 5 on your first roll and a 6 on your second? So you're going to treat these as individual events, and then we're just going to multiply the probability of each event together, and we should get the same answer that we got for the tree diagram. So what's the probability of rolling a 5 on your first roll? Let's just consider that. So you roll the dice once. There's 6 outcomes. How many of those outcomes are a 5? Just one of them. So you roll your dice. Chance of getting a 5 on that first roll is a 1 out of 6. Now, your second event, you're going to multiply this times your second event. So what's the chance now you get a 6 on your second roll? So the first event is done. We're not worried about it. We're just trying to find the probability of getting a 6 on your second dice. So there's 6 numbers you could get on that second dice, and only one of them is a 6. So the probability of my first event is 1 out of 6. The probability of my second event is also 1 out of 6. So each on their own has a 1 out of 6 chance. But what's the chance that they happen back to back? We need to multiply straight across. We're going to get a 1 on top. We're going to get a 36 on the bottom. And if you take a look, that's the same answer we got for the same question using the tree diagram. But look how fast this was. Okay, so once we understand how to use this principle, it's much, much faster and efficient. So next one, what's the probability of rolling 2 even numbers? So just on one dice, event number 1, rolling an even number. There's 6 numbers on the dice. How many of them are even? 2, 4, and 6. That's 3. So 3 out of 6. You're going to multiply that times the second event. So on your second dice, we also want to get an even number. So on your second dice, there's 6 options. 3 of them are even, 2, 4, and 6. So I'm going to multiply the probability of an even on my first times the probability of an even on my second. And that gives me 9 out of 36, which is what we started with up here. And that simplifies down to 1/4. Now, some of you might have saw 3 out of 6 and 3 out of 6 and automatically said, well, that's 1/2 and 1/2. So if you simplified early, 1/2 times 1/2, same thing as 3/6 times 3/6. You just get right to your final answer of 1/4. Okay, so you don't even have to worry about simplifying at the end if you want to simplify early. Again, same answer as we got up here. So we already know the answer we should get on these. Let's make sure we can use this principle to get it. So what's the probability of rolling 2 4s? So first event, and you don't have to write this every time, but the probability of rolling a 4 on your first dice is 1 out of 6. There's only one way to roll a 4 on your dice, 6 different options. Now you want to roll it again on your second dice. So again, when you roll that dice, there's 6 sides, and only one of them is a 4. So you're going to multiply, and you're going to get a 1 out of 36 chance of getting a 4 on both dice, which again is what we had right here. Okay, and then on the last one, what's the probability of rolling a 3 and a 5 in any order? So any order. So on your first dice, first time you roll it, you can get a 3 or you can get a 5 because it doesn't matter which one we get first. If we had to get the 3 first, then that's only a 1 out of 6 chance. But since I can get either one of these, that means I have 2 options out of 6. And then on my second event, a lot of people would say, well, then you have a 2 out of 6 chance on your next one as well. Here's the problem with that thinking. On your first dice, you could get the 3 or the 5. But on your second dice, you have to get the other one. Because getting a 3 and a 3 or a 5 and a 5 doesn't count in this situation. So we have to get a 3 and a 5. So on your first dice, you could get either one, 3 or 5. But on your second dice, you have to get the other one. So let's say we got a 3. The next time we have to get a 5. There's only one way to do that. Or let's say we got a 5 on the first one. Now we have to get the 3. And there's only one way to do that. So on your first dice, you can get either 1, 2 out of 6. On your second dice, then you only have one option, and it's a 1 out of 6. So we're going to multiply straight across. We're going to get 2 out of 36, which is what we started with here. And that's going to simplify down to 1/18. And if you saw that 2/6 was the same as 1/3, you could have simplified that early and multiplied it times the 1/6, and you would have got to the same answer without needing to simplify. Okay, so what I want you to do is I want you to try these questions on the back, give it your best shot, and then you're going to watch the next video and you're going to check your answers and then fix them if you need to fix them.